Mandavi, Deshpande-Garge from India. She's from APT Research Foundation. Mandavi has submitted her PhD thesis to the University of Hume and Maharashtra, India. She has done her master's in microbiology, also from this university. She has gained her research experience in different sectors like microbiology and toxicology. She is now research associate at APT Research Foundation. Welcome.
Good evening, everybody. Today, I was invited by OMICS group for this conference as a speaker. Then I asked the organizers that on what topic I should give my speech. Then they suggested that you can deliver your speech on therapeutic potentials of plant extract. So furthermore, I linked with my work. My work area is anti-obesity potential of plant extract. So I linked this topic with the therapeutic potentials of plant extract. I am from India, as introduced by Doctor. So APT Research Foundation is a private institution which is recognized by University of Pune, a very well-known university in India. So now I start my speech here. To introduce the topic, we all must say that nature is a great chemist. So nature has provided us food, medicinal sources, and as well as, since we are talking about this topic from 2 days, I must say nature has provided us the employment as well, because we all are working on these natural products. So different food products, that is carbohydrates, proteins, fats, vitamins and minerals are provided. Along with that, secondary metabolites nature has provided us, and we human are using those metabolites, which includes tannins, flavonoids, then saponins, alkaloids, steroids as a medicinal source for treatments of various diseases. The ancient Indian culture is Ayurveda. Also, we have a traditional medicinal treatment faculties as Unani drug and Chinese medicines, which have years of together the background of the therapeutic potentials of different herbs. Earlier, decoctions, then crude powders were used as a drug. In Indian cases, we used to prepare cloths, and then the modern science came, which needs and which is saying that there should be standardization of these traditional medicines. I must say that there are around 120 drugs which are available and which are originated from plants, and they are now patented drugs available in the market. These drugs, initially they are originated from plants, and certain drugs after that they are synthesized. The standardization of the chemically synthesized drug is more easy, as yesterday discussed, rather than the natural products. But there is an issue of toxicity, which is a major concern for chemically synthesized drug. I want to give a gist of the marketed drugs. It is a gist from 120 drugs which are available in the market. The first drug on malaria is a quinine, which is originated from Cinchona legeriana, is a plant, and now it is synthesized drug. Apart from this, now quinidine is also another drug, another compound which is originated from Cinchona legeriana and which is used for various heart diseases and conditions, and 4 patented drugs are available in the market for heart diseases. The famous drug, that is paclitaxel, which is originated from the plant product, that is Taxol, which is used as an anti-cancer drug. The Taxus brevifolia is the plant from which the Taxol drug has been isolated. Then betulinic acid is an anti-cancer drug which is originated from Betuna alba, and in another some plants also this betulinic acid is present. Ziziphus mauritiana is also one of the plant which contains this betulinic acid, and some clinical trials has been completed for this betulinic acid as an anti-cancer drug. The famous drug for Parkinson's, that is L-DOPA, which is originated from Mucuna species. For CNS depression activities, for CNS diseases, caffeine, which is originated from Camellia sinensis, is also available. These are the synthesized compounds or originated compounds from the plant extracts or plants. But in market, we have direct use of plant extracts which are used for different diseases or disorder. In case of diabetes, in India, Trigonella phenogrycum, that we call it as a methi or fenugreek seeds. This is used as an anti-diabetic treatment. Then the another thing is Momordica charanita. It is a fruit which has anti-diabetic treatment, anti-diabetic potential. One more metabolic disorder is obesity. So Garcinia cambogia and Commiphora mucul. The fruit of Garcinia cambogia is used as an anti-obesity treatment, and Commiphora mucul stem, they have isolated one part, that is gubulosterone, from the stem, and which is used for anti-obesity treatment. Then for cardiovascular diseases, a famous Indian drug, Arjuna Arishta, is prepared from Terminalia arjuna, from the bark of Terminalia arjuna, and it is used for cardiovascular diseases. For liver damage, Cybium marium leaves are used, and another famous drug from India is Leaf 52 is used, which contains different plant extracts, is used for hepatoprotective activity. As I said that my area was obesity. My work was on Ziziphus mauritiana bark extract. So majority of my work is related to anti-obesity potential of Ziziphus mauritiana extract. I have submitted my thesis on the anti-obesity activity of Ziziphus mauritiana bark extract. So my focus is on obesity. So diseases which are associated with obesity, as we all know, is diabetes, then cardiovascular diseases, different cancers, infertility, and inflammation. Before going in details of obesity, obesity is related to the lipid metabolism and energy expenditure. So it is better to know how the lipids are metabolized. By the food intake, lipids are ingested, they enter into stomach. Different bile acids from gallbladder and lipase from pancreas, they act on this lipid. Different lipases cleave these lipids into monoglycerides, triglycerides, and these are then entered into intestine and then get absorbed into blood. Through blood, these lipids, either they are used for energy generation or they are directly deposited into adipocytes. While considering the anti-obesity drug, we have to think on different properties that should have for an anti-obesity drug. This anti-obesity drug, it should have one of any property of the different mechanisms. So it should decrease the lipid absorption, it should decrease the energy intake, it should increase energy expenditure, as Dr. Frederick talked yesterday about the effect of flavonoids from humulus lupulus, which is increasing the energy expenditure. It should decrease pre-adipocyte differentiation and proliferation. It should decrease lipogenesis and increase lipolysis through beta oxidation. So this is the plant, that is Ziziphus mauritiana. It was authenticated, and I have used bark of the tree. The bark was isolated from the tree and it was dried, and then this bark was ground into powder. Different serial extraction was done of this powder form. So serial extraction, I've got chloroform extract, ethanol extract and aqueous extract. So I have done the quantitative phytochemical analysis of these extracts. In that I found that chloroform extract showed absence of catechin, quercetin and gallic acid, but ethanol extract showed tannins as a catechin and flavonoids as a quercetin. Here I found gallic acid in a very negligible amount. Then aqueous extract showed presence of tannins as catechin and flavonoids as a quercetin. While I was going through the literature, I found that tannins are responsible for adipocyte differentiation inhibition, and flavonoids have a property to increase glucose uptake. I've done antioxidant activity assay by ABTS cation oxidation assay. So chloroform extract at 100 microgram per ml showed 40.81% inhibition, and ethanol and aqueous extract showed 100% inhibition. And I calculated the corresponding equivalence to the ascorbic acid. As in earlier slide, I showed that in lipid metabolism, role of pancreatic lipase is very important. So I studied in vitro assay to determine whether these extracts have lipase inhibitory activity. So the aqueous extract showed 100% lipase inhibitory activity at 400 microgram per ml. This was an in vitro assay, but this was further correlated to the animal studies. To study the adipocyte differentiation inhibition by aqueous extract, that is Ziziphus mauritiana bark aqueous extract, further I will call it as a ZMBP EAQ. Before studying the inhibition assay, it was necessary to study the cytotoxicity of this extract. So cell viability assay was done on L929 cell line. These L929 cell line are the mouse fibroblast, and it is recommended by USP chapter 87 and ISO 10993 part 5 that the medical devices or pharma products or pharma packaging material can be tested on L929 cell line for their cytotoxicity. And you can see that the aqueous extract at 1 mg per ml is showing good viability, whereas cerulin is a standard drug which is used for adipocyte differentiation inhibition assays, is showing cytotoxicity on L929 cell lines. This is the adipocyte differentiation inhibition assay. These are the photographs. So you can see the in the control sample, in the control whale, large adipocytes which are stained with oilo red stain, and the fat globules are there inside the cells. And these are the test sample bales in which there are small adipocytes with very less oil droplets. These oil droplets are further extracted in isopropanol, and I've done the spectrophotometric analysis, and you can see the standard drug showed a dose-dependent decrease in the oil, that is fat globule formation, and my extract also showed a dose-dependent decrease in the fat globule formation. This is the induction control, which is showing larger fat globule formation. So this assay shows that there is a definitely adipocyte differentiation inhibition at 400 microgram per ml concentration. Further, I have done one study to study the effect on glucose uptake with the extract. So this is called GLUT4 transformation activity on CHO-HRC-MUC GLUT4E GFP cells. These are the modified CHO, that is Chinese hamsters OD cells, in which on the cell membrane this GLUT4, the cell membrane of this cell line has been modified to express the GLUT4 on the cell membrane. So in this assay, insulin was used as a standard drug, and the ZMBP aqueous extract was added at the concentration of 10 microgram per ml and 50 microgram per ml. After addition of this, photographs were taken. In the well, labeled glucose, that is D2O glucose, has been added. So you can see the photographs in which this is the emission of this radio labeled glucose. Then after taking photographs, the cells were, after taking photographs, the reaction was stopped, that is terminated, and the protein was harvested, and then by scintillation camera the radioactivity was measured, and inside the cell the insulin showed more uptake than the control, and also the cells treated with 5 microgram and 50 microgram of aqueous extract showed increased glucose uptake rather than control samples. This experiment showed that after addition of the Ziziphus mauritiana aqueous extract, there is increased glucose uptake in the cell line, which is compared to the insulin. After completion of the in vitro studies, then I further went for the in vivo studies to study the actual effect of the Ziziphus mauritiana bark extracts on obese mice. So firstly, I've developed B6D2F1 mice by high-fat diet. So I've given for 30 days high-fat diet, and after 30 days I have confirmed that the animals are obese by increased body weight, anthropometry, insulin resistance, and then these animals are divided into different groups. Per group the number of animals was 6. So administration of the drug was by oral route, and along with that orlistat was used as a standard drug. Because this drug showed lipase inhibition activity, so I have used orlistat as a standard drug, which is a lipase inhibitory. So these are the results. There is a statistically significant decrease in the body weight at the end of 30 with the Ziziphus mauritiana bark extract and the standard drug. Furthermore, I have done during my study the anthropometrical measurements to measure the thoracic and abdominal circumference. So you can see there is a significant decrease in the abdominal circumference compared to the obese control. At the end of 30 days, I've dissected the animals, I've taken out the epidermal fat pad and peritoneal fat pad tissues. And there was decrease in the peritoneal fat pad tissues in ZMBP aqueous extracts as well as standard drug. These are the photographs of, this is the obese animal. You can see the treated animal which is lean. After dissection, rather than prior than dissection, I have taken out the blood to determine the lipid profile of the blood. Then after dissection, I have taken out the liver tissue, epidermal fat pad and peritoneal fat pad, and I have measured the triglycerides content in the different tissues. The serum profile showed that the aqueous extract treated and standard drug treated showed less serum triglycerides and less cholesterol as compared to the obese control group. Also, the liver triglycerides are less in the treated group compared to the obese control group. I found that there was a very less effect on the epidermal fat pad as the weight as well as the triglyceride content. The peritoneal fat pad significantly showed decrease in the triglycerides content. I have analyzed the fecal, I have collected the fecal fat on day 0 as well as day 30. So the fecal fat excretion was increased in the aqueous extract group and the standard drug group. After dissection, I have taken out the pancreas and done an assay to determine the pancreatic lipase activity by paranitrophenol palmitate assay. So I found that the pancreatic lipase activity was significantly decreased with the aqueous extract and the standard drug. So this correlates that decreased pancreatic lipase activity is correlated with the increase in the fecal fat excretion. So increased fecal fat excretion, increased energy expenditure, increased glucose uptake are related to decrease in the body weight. So to summarize my findings, that all these extracts showed antioxidant activity. In obesity, there is oxidative stress. So probably the antioxidant activity of aqueous extract is helping out to decrease the oxidative stress generated by obesity. Then aqueous extract showed lipase inhibitory activity. It also showed pre-adipocyte differentiation inhibition, which was induced by IBMX and insulin. It also showed insulin-like glucose transport stimulatory activity in the modified CHO cells. In the present study, we have observed that reduction in body weight gain, decrease in triglycerides content, decrease in pancreatic lipase activity, which is associated with increased fecal lipid excretion in ZMBP aqueous extract fed obese mice. Here I want to say that this aqueous extract was not further analyzed, only the flavonoid content was measured, but the further work for the active component, we have to do it, and we are in process of doing this work. But I am finding difficulties in isolation of the compound through aqueous extract. So after completion of this work, I can definitely publish my work related to the active component of these things. I acknowledge my guides, Dr. Parab and Dr. K.G. Apte from Apt Research Foundation. This glucose uptake assay was conducted at National Center for Cell Sciences under the guidance of Dr. Vijay Kumar and Dr. Manoj Kumar Bhatt. So I thank them. I acknowledge the staff of National Toxicology Center, which is my parent institution, and Apt Research Foundation, Pune, India, for their help for doing my work. I also thank the organizers for giving me this opportunity to present my work. Thank you very much.
Due to the time, only one question. Okay.
Yes.
So I'm not familiar with your mouse model. What is it exactly? Is it a genetic model?
This basic D2F1 mice, these are the F1 generation mice of C57BL6 and DBA mice. So these B6D2F1 mice, there are some references that these mice can be used for the study of obesity. So these mice were purchased, these F1 generation mice were purchased, and I have given the high-fat diet to become them obese. So it is diet-induced obesity model.
So
it is
these
not
are the-
knockout mice.
This is not the 6J strain.
No, it is not C57B6J. It is not that strain.
Okay, thank you again.
Thank you.